Hello, this video is going to go over systems of equations. Now, a system of equations just means more than one equation put together. In other words, now we're looking at two equations at once or three equations at once. And the solution to a system are values that make each equation in the system true. So in other words, the coordinate 2, 3 would work for the first equation, and it also works to make the second equation true. So when we're looking at a graph of a system, did not mean to move it, there we go. When we're looking at the graph of a system, and it's asking us to find the solution for it, we have a system here because we have 2 lines being graphed. So this is a system of two equations. Their solution is the intersection. So in this case, the solution would be 1, 5, because it's on the first equation and it's on the second equation as well. 1, 5 exists for both equations in the system. So for number 2, when it's asking for the number of solutions in each system, it's asking how many intersections are there. This one has 1, 2 intersections, so it's going to have 2 solutions. The second one has 1, 2, 3, 4 intersections, so it has 4 solutions. And the specific solutions would be whatever coordinates they happen to be at. Keep in mind, if your graphs don't intersect at all, then we say that there are no solutions because they are imaginary. So we are going to recall that a system of equations involves 2 or more equations. Remember that the answer to a system of equations must satisfy all of the equations. And graphically, the solution to a system of equations is the point of intersection. So we have 2 equations graphed below, the red and the blue, and they're asking to find the solution to a system of equations. How do I know it's a system? They're writing one equation above the other, and it's telling me this system has 2 equations. The solution to them are their points of intersection. So our specific solutions are going to be So the solutions are going to be 0, 3 and 4, -5, because that's where they intersect. Now part B is worded a bit differently, and that wording makes a huge difference. It's not giving you a system here. You don't see the word system. It's saying there is one equation. Here there are 2 equations. Here there is 1 equation. Because it's not plural, it is not a system. They're saying to set f of x equal to g of x. So negative 2x plus 3 equals g of x, which is x squared minus 6x plus 3. Now you guys know how to solve equations. This is one equation, the left equals the right. We have to set it equal to 0 if we wanted to solve. So I'm going to bring over the 2x, and I'm going to bring over the 3. And if I were to do that, I'm going to get x squared minus 4x. And you can factor this by GCF. So I'm going to get x times x minus 4. And that's going to give me 2 answers, x equals 0 and x equals 4. So let's compare how that's different here versus our last answers. First of all, I have to say that if you want to put this in set notation, you would use curly brackets. So notice how here, in the last example, parentheses is a coordinate, whereas curly brackets represents a solution set. And if we go further and if we examine the difference between these answers, we could see how the wording makes a difference. When there is one equation, we only had x values as our answer. But when there was a system, we needed coordinates, x and y. So it's really important. Anytime you see the word, or rather this phrase, f of x equals g of x, it means x values only. We didn't even have to solve it algebraically. You could have just looked at the x values, x equals 4, x equals 0. But they will try to get you in multiple choice questions where they say, find the solutions to f of x equals g of x. But they'll give you these coordinates instead of giving you the x values only. And you need to know my answer is not a coordinate when they say f of x equals g of x. And we're going to practice this more in class. So to sum it up, if the equation asks to state the solutions for f of x equals g of x, only state the x coordinates. For the points of intersection. If the problem asks you to solve the system, then you have to find both x and y for the coordinates for the points of intersection. In other words, if you are writing the answer to a question and they are all the same variable, such as x equals 2 and x equals -3, that goes into a solution set. However, if you have different variables, x and y, that becomes a coordinate, which would be 2, -3. So that distinction is very important. Are you talking about a coordinate for a system? Or are you talking about a solution set for f of x equals g of x? Tomorrow, we're going to go over how to actually find these points of intersection on your calculator, because you're not always going to be given a graph to just look at. And that's all for this video.